Hello, and welcome to this session on accelerating scientific discovery with NVIDIA and HPE. Scientific computing today is about more than flops. Insights and discoveries are being realized through a variety of computing paradigms, such as data analytics, artificial intelligence, and advanced visualization. The data which is being analyzed is also now gathered increasingly from a broad range of sources, such as cameras and sensors in remote locations. All of this together has given rise to new ways of designing HPC solutions. HPE and NVIDIA are leading the next wave of scientific supercomputers. One example is Theta GPU at Argonne National Labs, which runs almost 200 GPUs and uses NVIDIA Mellanox InfiniBand HDR 200 gigabit per second and switches. Some other examples coming soon include the newly announced Euro IT for Innovation system, part of Euro HPC, which will run almost 600 GPUs, and Perlmutter at NERSC, which will eventually have over 6,000 A100 GPUs. One of the most exciting areas in scientific computing, and one of the most important ones for the present time, is the use of AI and data analytics combined with traditional HPC to help in the fight against COVID-19. Researchers from the Technical University of Munich and other institutions are using AI to map 3D protein shapes. 3D mapping enables the discovery of therapies that bond to proteins, such as those in the virus that causes COVID-19. As you know, a protein is made up of amino acids in a 1D sequence. These amino acids follow certain constraints, like the rules of language that map their 3D shape. By treating amino acids as words and using AI natural language processing models, researchers train models to translate protein sequences into encodings. These can be used to replace database searches with a fast AI inference model. At Oak Ridge National Lab, researchers created a data science infrastructure to analyze, sort, query, and process output from 2 billion calculations. This post-processing analysis would have been very difficult to do before, but now they are running full scans and sorts on terabytes of genomics and cheminformatics data in seconds with GPU-accelerated computing. NVIDIA today provides a complete platform for scientific computing with the ability to accelerate data analytics, simulation, artificial intelligence, visualization, and more. NVIDIA GPUs and NVIDIA Mellanox networking combined with servers from leading manufacturers such as HPE to provide the most powerful platform for accelerating a wide range of algorithms and applications. But it's not just the hardware. NVIDIA has a full stack of software for developers, from GPU-enabled compilers to libraries and toolkits for accelerated computing. Researchers can make use of the over 700 applications that have been optimized for GPUs. Just about every problem domain has benefited from hardware acceleration. NVIDIA's platform also has integrations with the leading HPC management tools, enabling IT managers to easily manage and operate servers built on this platform. The NVIDIA A100 Tensor Core GPU, released earlier this year, represents the greatest generational leap in GPU performance. This new architecture brings a whole host of new features to accelerate all workloads. The third generation of Tensor Cores provides up to 20 times greater performance for AI workloads without any code changes, and up to 2.5 times greater performance for FP64. The second generation RT cores provide up to 2 times greater throughput for rendering operations. NVLink and NVSwitch technology enable multiple GPUs to work together on a single calculation. And the third generation of these technologies enable up to 2 times more bandwidth for data movement. A new feature called sparsity acceleration takes advantage of sparsity in AI models to provide up to 2 times greater performance. Finally, the new multi-instance GPU allows you to divide a single A100 GPU into 7 independent instances on the fly, enabling optimal utilization for multiple purposes as needed. On the networking side, InfiniBand continues to be the top choice for HPC infrastructure. NVIDIA Mellanox InfiniBand provides 200 gigabits per second end-to-end bandwidth, extremely low latency, and high message rate. Advanced adaptive routing, congestion control, and quality of service provide the highest network efficiency. In-network computing engines accelerate the performance and scalability of scale-out applications. And self-healing networks provide the highest network resiliency. Best of all, these technologies are based on standards, which enable both forward and backward compatibility, ensuring the protection of data center investments. On the software side, one of the newest areas that NVIDIA has started investing in is the acceleration of networking and storage I/O. NVIDIA Magnum I/O is the I/O subsystem for the modern accelerated data center. It offers libraries, SDKs, and services to help developers design their applications, frameworks, or infrastructure to run optimally on high-performance GPUs, storage, and switching fabric. One example technology is GPU Direct RDMA. By enabling data to bypass the CPU and move directly from GPU to GPU on separate nodes, applications can benefit from up to 10 times better performance. Another technology called SHARP, which stands for Scalable Hierarchical Aggregation and Reduction Protocol, enables computing to happen in the network layer itself, giving up to 2 times better performance for MPI and other scale-out applications. The newest addition to Magnum I/O is GPU Direct Storage. By enabling GPUs to access data from storage devices directly, the data movement experiences higher bandwidth, lower latency, and less jitter. If you look at a basket of top applications for simulation, AI, and data analytics, you can see that NVIDIA's full stack innovation has resulted in continuous performance improvements over the last 4 years. In the case of the previous Volta generation of GPUs, this performance improved by 2 times due to software innovations alone. By choosing a server infrastructure based on the NVIDIA platform, customers can experience top performance today and be secure in the knowledge that this infrastructure will continue to serve them well into the future. HPE is releasing NVIDIA certified servers that customers can buy to get up and running right away to build their AI and HPC solutions. The Apollo 6500 Gen 10 system provides high-density compute with 8 A100 GPUs, while the DL380 Gen 10 is designed for enterprise deployments, having 2 A100 GPUs. Both systems share a common system board architecture, and they benefit from high security with Silicon Root of Trust, enterprise management with ILO and HPCM, and enterprise support from both HPE and NVIDIA. These systems provide superior performance per dollar for GPU-intensive workloads. Customers benefit from unprecedented flexibility and performance, and rock-solid enterprise-level reliability, availability, and serviceability. HPE and NVIDIA together provide solutions for HPC that help customers solve the most challenging problems of today and tomorrow. Thank you for attending this session. Have a nice day.